Hi and welcome to another video for Year 9 Maths D under the chapter Limits of Accuracy, and the second subtopic that you are going to do is know how to do estimation, but you have to make sure that you remembered how to run off according to the specified decimal places and significant figure. So let's start with this: estimating answers to several problem. In most cases, to estimate answers to problem, you can first, what you have to do is to round each number to one significant figure, and then you carry out the calculation. So here, let's have a look at this example. Number 1, estimate the result of each of these calculations by rounding to one significant figure. So let's start with A, right? So A, 3.7 times 2.1. Since we don't have to be too accurate, so you round off everything to one significant figure. So this is actually 4 times 2 after rounding off, and your final answer will be 8. Right, let's move on to part B. 47 times 63. Round off everything to one significant figure. You will have 50 times 60. So this is actually 3,000. Okay, right. So the next one is part C, where 4.32 times 8.76, which is 4 times 9, and this is 36. Now here, do not try to be accurate with answer. You give your answer correct to one or two significant figure. So actually for this one, you have two answers. It's either 36, or you can round off once more to get 40. All right. So for part D, for the next one here, 2.95 times 0.321. So be careful over here. The first significant figure is after the decimal point, which is number 3. So here you will have 3 times 0.3, and this is 0.9, which is already one significant figure. And last but not least, here 0.815 divided by 3.41. So here you will have 0.8 divided by 3. And here, when you try to divide this, you actually have 0.2666, which is recurring. So just round this off straight away to one decimal place, and you will get 0.3. Okay, so that's for example number 1. The next example over here, okay, please just now I use this symbol because I want to indicate approximation. So here, let's continue with example number 2. Jim buys 24 golf balls at $3.75 each. So the question is, what is the approximate cost? Now, just before this, you have to basically round off the quantity, the number that you see to one significant figure. So here, since you know that one ball approximately equal $4, and he buys 24 golf balls, which is about 20, right? So here, when he buys 20 golf balls, which is priced at $4, so your calculation will be 20 times $4. So your answer will be approximately equal to $80. Okay, that's the approximate cost. Right, now here, sometimes you will have numbers that involve division and square roots, so you have to sometimes use numbers that is easier for you to divide or to use square roots. So let's have a look at example number 3 over here. So here, find approximate answers to this. So here for part A, 83.7 divided by 2.87. So for the first glance, that here, your first instinct will be rounding off 83 into 80. But here, let me just find out first the division. So under the denominator will be 3. So when you run off 83.7 to the nearest one significant figure, you will have 80, right? So this 80, you cannot divide it by 3. So it is better for you to run off to whatever number that is a factor of 3. So here, for example, the first one here, so 83.7 is approximately equal to 81. Okay, so let's find out the calculation. So 81 divided by 3 is 27. Or you can say that you can round off 83.7 to 90 and then divided by 3, because 90 can be divided by 3. Or you can say here 90 divided by 3, your answer is 30. Okay, but here let's choose this one, because this one, when you calculate 83.7 divided by 2.87 by calculator, this answer will be nearer to the actual answer. So we will use 30. Okay, and then part B, 0.73 is basically 0.7 times, right, let's have a look under the square root. Now under the square root we have 18.2. So when you try to say that 18.2 round off to one significant figure is 20, 20 cannot apply square root. So you have to use the nearest perfect square to 18.2, which is 16, right? So here let's have a look at the result. 0.7 times 4, which is actually 2.8. Okay, this is if you are deciding to use two significant figure, but if you decide to run off further, become 3, this is actually to one significant figure, right? Up to you, right? Now let's have a look at this one. Okay, when you are measuring or calculating something, you should express it to a suitable degree of accuracy. For example, let's say for a train journey, if the time taken, okay, let's say you are informing people, will you tell them 4 hours, 46 minutes, and 30 seconds? Or it is much more making sense to say that it took about 4 hours? Exactly, right? So let's say the time taken will be about 4 hours. And then at the distance here, this is the actual, the exact distance, 93 kilometer, 484 meter, and 78 centimeter. You will not tell people that, so it is more sensible to state it as about 93 kilometer. So here, as a rule in general, the answer that you give after a calculation should not be given to a greater degree of accuracy. Means here this is correct to the nearest second, but your answer is at a less degree of accuracy. So this here is correct to the nearest hours, but here also you are giving the answer correct to the nearest kilometer rather than to the nearest centimeter, right? So that is the less degree of accuracy than any values used in the calculation. Right, so let's have a look at the next example. Okay, example number 4. Bilal measured the length and width of a rectangular table as 1.84 meters and 1.32 meters. So he calculated the area and he found out that 1.84 times 1.32 is this one, 2.4288. So how should he have given the answer here? Let's have a look here. This one, your answer is 4 to 4 decimal places, right? But your measurement is 2 decimal places. So he should give his answer as this one. This is approximately. You will also give correct to 2 decimal place. So you will have 2.43 meter square. So he should have given that answer, right? Or you can say, if you want to make it less greater, you want to make it simpler, you can tell 2.4 meter. So you just have to tell this is the first digit here is 2.43. This is 2 significant figure, and the last one is 1 significant figure. So I think that's it for the topic of estimation. I hope that it can help you understand the concept. So that's it. Thank you very much and see you next time.